Hello everyone, I am Sunil Kumar and in this lecture I am going to solve a recurrence relation using substitution method. So see, this is very interesting question and you will learn something new in this question. So let us solve this question with the help of substitution method. So see, let us assume this is my equation number 1 and let's say let me simplify this. Actually this is nothing but it can be written in n raised to power 2. So let us simplify this. So it is going to be 2t of n raised to power 1 by 2 we can write plus log base 2n. Now see, I need to find the value of t of n raised to power 1 by 2. So how can I find the value of? So in the similar approach, in the previous videos I have already explained this, concept. So what we can do, let us write the first equation. So t of n equal to, so it is nothing but 2t of n raised to power 1 by 2 n raised to power 1 by 2 plus log n. So this is what equation number 1. Now what we can do, if I simply replace n by n raised to power 1 by 2, n raised to power 1 by 2, then I'll be able to find the value of t of n upon n by n power 1 by 2. So let us substitute this. So it is going to be n raised to power 1 by 2 equal to 2t of if I replace this n by n raised to power 1 by 2, so it is going to be n raised to power 1 by 2, and that already that power is already available 1 by 2. So plus, now it is going to be log n raised to power 1 by 2. So let us simplify this. It is going to be 2t of n raised to power 1 upon 2 square plus log of n base 2. So this 1 by 2 will come this side. So let us substitute this in this given equation. If I substitute, so let me write this 2 as it is, and let us substitute the value of t of n by 2 in this equation. So this log n will be as it is, log n. Now, so I know the value of t of n raised to power 1 by 2. So this is the value. Let us substitute. So this is going to be 2t of n raised to power 1 upon 2 square plus 1 by 2 log n base 2. So let us simplify. So it is going to be ultimately 2 square t of n raised to power, it is going to be 1 upon 2 square plus if you multiply this, so it is going to be ultimately log n. So log n and plus this log n. If you further simplify, so it is going to be 2 square t of n raised to power 1 upon 2 square plus 2 log n. So let us see. I'm not able to understand what series I'm getting in this question. So let us say let us substitute one more time the value of t of n raised to power 1 upon 2 square. So let us see how to find the value of t of n raised to power 1 upon 2 square. So simply I will replace n by n raised to power 1 upon 2 square. So let us replace. So this is going to be t of n raised to power 1 upon 2 square this time. So it is going to be ultimately 2 raised to power t of n raised to power 1 by 2 is already there, and you are replacing n by n raised to power 1 upon 2 square. So it will become, so 2 cube plus and log, so you are replacing n by n upon n raised to power 1 upon 2 square. Now let us further simplify this. So it is going to be 2t of n raised to power 1 upon 2 cube plus, so 1 upon 2 square will come this side, and it is going to be ultimately log n. Now let us again, so this is what the value of t of n upon 1 upon 2 square. So let us simply substitute in this equation. So 2 square will be as it is. Now the value for this particular t of n raised to power 1 upon 2 square is what? 2t n raised to power 1 upon 2 cube plus 1 upon 2 square log n base 2. So now this 2 log n is already there, 2 log base 2 n is already there. Now see, so if I further simplify, so it is going to be 2 cube, now t of n upon 2 cube, not 2 cube, sorry, so it is actually n raised to power 1 upon 2 cube plus if you multiply this, so it is going to be 2 square, so 2 square will be cancelled, so it is ultimately log base 2n plus 2 log base 2n. Now if you further simplify, so it is going to be 2 raised to power q t of n raised to power 1 upon 2 cube plus log, so it can be added, so it is going to be 3 log base to n. So now I understood pattern. If I substitute one more time, so it is going to be 2 raised to power 4 t of n raised to power 1 upon 2 raised to power 4 and 4 log base to n. So now let us substitute up to kth term. If I substitute up to kth term, so let us see what will be the series. So it is going to be 2 raised to power k t of n raised to power 1 upon 2 raised to power k plus k into log base to n. See, now here it is interesting, but I do not know the value of n raised to power 1 upon 2k. So what I can do, I can simply replace this by 2. Let's say let me assume n raised to power 1 upon 2 raised to power k equal to let's say 2. See, why I am assuming 2? Because if you take log both the sides, so let us take log both the sides, so log base 2 n raised to power 1 upon 2 raised to power k. If I assume 1, so it is going to log 0, so everything will be 0. So let us take log both the sides, so it is going to be log 2. Now it is actually this value is going to be 1. So let us further solve. So it is this value will come this side, so this is going to be 1 upon 2 raised to power k log base to n equal to, so this is what, 1. Now let us further simplify, so it is going to be log base to n and it is going to be 2 raised to power k. Now if you take one more time log, so it is going to be ultimately k value is what, log base to n. So this is what the value of k. Now so what we can do, k value is what, log n, so let us replace 2 raised to power k is what, log base to n. Now so t of, I have assumed this value what, I have assumed this value so 2, yes, so t of 2. So let us consider this is the termination condition, t of 2 is 1. So termination condition will always be constant, so we can assume anything, depends on the question. And t of 2 plus, now what is the value of k? K is nothing but log n. So k is what, log base to n. So this is k and log n is already there, log base to n is already there. Now so which term is dominating term in this? So here log in is log in, and here we are multiplying with log n. So this part is definitely greater. So time complexity would be, what will be the time complexity? Time complexity is going to be log n and into log n. So this is going to be your time complexity if you will write, so order of log n, or it can be written as also order of, first you can write log n, then you can write log n. So this is base, so you can write simply like this. So this is the time complexity for this question. So this question is very interesting question.